The calibration of meters under actual operating conditions is the key to accurate measurement. One of the most widely used provers is a bidirectional sphere-type displacement prover, which is used to calibrate all types of meters: positive displacement, turbine, Coriolis, and ultrasonic. All displacement provers operate on the principle of a calibrated volume between two detector switches, which is directly traceable to a metrology standard. In this animation, we see a Smith positive displacement meter, shown in red, upstream of a bidirectional sphere-type displacement prover. In normal operation, the fluid flow, depicted by blue arrows, only flows through the meter. To prove the meter, the flow is directed through the prover by opening the valves upstream and downstream of the prover and closing the valve in the main line downstream of the meter. These valves are typically block and bleed valves, which provide a means of positively checking that there is no leakage through the valve and that all the flow has been directed through the prover. After the flow is completely diverted through the prover, the four-way valve is actuated, which reverses the flow through the prover. This launches a sphere in the forward direction through the prover bore. Focusing our attention on the meter, we see the pulse stream from the transmitter on the meter being fed into the pulse counter. Each of these pulses from the meter represents a small volume of fluid that has passed through the meter. As the sphere contacts the first detector switch, the pulse counter starts counting the number of pulses received from the meter. When the sphere contacts the second detector switch, the pulse counter is stopped. Since this is a bidirectional prover, once the prover pass is completed, the four-way valve is reversed and the sphere is launched in the reverse direction. The pulse counter is once again activated by the first detector switch and stopped by the second. This cycle is repeated a set number of times, and the results are used to verify the repeatability of the meter. The totalized pulses on the counter represent the precise fluid volume that has passed through the meter during the respective prover passes. This indicated volume is then checked against the prover volume between the detector switches, which is accurately calibrated to a known standard. The meter's indicated volume can then be adjusted to equal this precise volume by means of a meter factor. After the proving session is complete, the three block valves are reversed, so flow is no longer diverted through the prover, allowing normal meter operation to resume.